Hi everyone. In this video we're looking at the request example. So last week in a discussion on LinkedIn again, we were discussing different ways of controlling outputs in sequences. And I mentioned that I always use this request sort of pattern where a sequence requests for an asset to have an output. And by using this method, it means that I can have more than one sequence control an asset without using set coils or without having sort of bits intertwined between sequences. It means that I can have two function blocks that don't know anything about each other, such as these two here, but they both control the same outputs via this request handler. So just to give a brief overview and an example of how this works, I have two layers here that have different conditions for each of their outputs, but they both control the same devices. So I have device A, B, and C. You see that both layers have outputs for those devices, but they write to a request layer. So if we look at our interface here, I have a temporary request structure, and in there I have layer A and layer B, and both of those have A, B, and C requests in them. And these are written to here, and the same for B is written to there. So that should sort of give the gist of it anyway, that every single output from a sequence or a function block that is utilizing this method has a dedicated place to write a request to. And then if we look at where those requests go, that entire structure is passed into this request handler, where inside this request handler we have a set of rules that determine what has the right priority to actually turn the output for the device on. So if I was to come into this and have a look, we can see that right now we have a request for device C from both layer A and layer B, and because there's no request at all from either layer for A or B, then device C output is allowed to be turned on via the request handler. But if I go and turn on layer A, so let's go and have a look. So if I go to layer A and I try to turn on device B request by turning on the condition 1, we see that that request goes through correctly. But if we go back to our request example, the parent block, we can see that the output is on the request layer, and we get a device B output through the request handler, but C has now gone off, even though layer B is still calling for C. And that's because in our request handler, there's a priority, and the priority is that it doesn't matter which layer is calling for it. If device B is on, device C is not allowed to be on. And you'll notice that layer B has no idea that layer A is now blocking the request. It doesn't matter because they don't know anything about each other, but without them knowing about each other, I can still give that priority between the two. So the same is true for other situations as well. If I go into B now, let's go online. So B right now has got no conditions, but if I turn off C, so turn off condition 2, and then I turn on all of the other conditions, which is 4, 5, 6, and 7, the device A is now being requested, and we go and have a look at what's happening here. So I can see A and B are both on, but coming out of layer A again, we're still seeing that C is being requested by layer A. C is still not on because the same rule applies, that A and B are now both required between the two layers, so it's not allowed to be on. So hopefully this shows an example of how we can have more than one object controlling, or one function block really, controlling an actual output. So looking back here, we've got layer A and B both writing to the same assets, but depending on how this request handler is configured, we change the priority, we allow or block signals to go through to the actual outputs. Now we could add in layer C, D, E, and build up more request layers that go into this request handler to manage those devices without having to go back to layer A and B and change them. And that's quite a strong selling point for this particular type of control. When more assets come online or more methods of control come into a project, you shouldn't have to revisit old ones, because it's actually this request handler, which is the bit that ties everything together, but it's decoupled from the area in which those requests are made. And it's the same for if you are adding more devices as well. This request structure simply grows, and it all comes back to this request handler. You can actually nest this as many times as you want as well. So whilst we have layer A and layer B feeding into this request handler, these outputs, instead of directly going to these Q variables here, which are physical outputs, so I/O cards or whatever they're attached to, you could actually have them going to another request block or outputs of this function block that we're in right now, and then the next parent up has a request handler that handles the requests from this block. So when you're doing nested sequences, you can still follow this this request structure through right the way up to the parent object, and then that decides what outputs are allowed to come in and out. So I hope that makes sense, but if it doesn't, simply drop us a comment below, and I'll do my best to clear that up. And be sure to follow and check me out on LinkedIn as well for more handy stuff.